So of phenol, IAA, water, and the overall, you have to take 3 out of.
Because one of them is dependent on this.
Yes.
I don't know. I'm just getting 3 degrees of freedom, and I don't know.
How many unknowns?
You have 7 unknowns, 3 material balances, and 1 extra piece of info.
No, you have 2 pieces because you have the ratio and the 90. So that's 2. And if you pick a basis, that's 3.
I'm assuming we've already picked a basis. Otherwise, if you didn't pick a basis, you'd have 8 unknowns.
I think we're still. I think we're still one short.
How do you solve this? I don't know the question.
VJ,
Yeah, I don't know.
I'm with it with like most of what we're talking about, but I'm still not quite sure physically how you could extract 90% and say that 90% is going to this stream, and then say that the ratio is 3 to 1, because logically wouldn't 10% go to the other stream? So then wouldn't it be a 9 to 1 ratio? So then I just don't get how that could even work.
Oh, that's a good point. So maybe this is not supposed to be there.
No, that's correct. No, it's V over L. No, no Y or X, according to.
No,
That's just
I
the
think that's
answer.
I think that's
We're not
right.
looking at the answer.
I think that has to be. I think there's no way you can make 90% come out and go to that one stream and then say that has a 3 to 1 ratio. It just doesn't make sense unless the phenol's like reacting or disappearing, which it's not.
So you're just saying it's the ratio of mole fractions.
I mean, I don't unless there's another way.
That's the only way it makes sense.
Yeah, I think so too.
Yeah, no, you know what? I think it is this, because if you think about any other equilibrium data, it's always in terms of y and x. It's never
So it's saying the concentration of phenol in the IAA stream is 3 times the concentration of phenol in the water stream, not the amount.
That makes sense, yeah.
So then the equation that we had, should that have been equal to?
Which one? No, this one I think is still good. This one over here.
5, 6, 7.
So you're, so that's
So then you can replace or replace Y1P with grade X.
Right. But how would that be solved?
I don't know. I haven't thought of it.
Just slowly turning your diagram.
Yeah, I thought I didn't know this one.
You didn't know how to?
It doesn't seem like a likely.
No, I thought.
It should be the same. Just turn your diagram, isn't it?
But that does let you solve X1P. I mean, that comes in as.
They might fuck up the whole decision.
Water fluid.
Because you don't have L.
It's easy. That's just how we've been doing it, right?
That was easy.
That one is easy.
Right, I don't know.
So you just bring it back like fucking
Yeah.
like we've already done this so many times.
Email that I sent you. I was having problems with the degree.
Yeah.
I tried to solve it, but I saw the proportion like ratios with the L over L0.
Right. So you had this, right?
So you're running for another information.
You put it in terms of say.
You say dy over.
You had both of those, right? So these are 2 different things, and it depends on what the wording of the question says.
Over LX.
There's
So-
composition of the most volatile components.
Is it the percentage of the charge, or is it of the percentage of the more volatile component?
Oh, so if it's the percent of the charge,
Total volume.
it's the one where it's like total
Yes.
amount. The percent of the
Right.
Isn't that?
Yeah, I think we found out the answer.
Use this and then also say
I just don't understand what we're talking about. Yeah, so if it's B over L, that's the percentage of the
I don't.
Hey, Aaron, are you saying V1 in that one?
Just the formula. It's always just find the right formula. Well, I didn't know that good.
The Rayleigh still one? The just recovery?
No, because that's a 3 component.
Oh, I don't know that one.
If you want
Why 100? Use one.
Wait, so did he just solve it?
There you go. Good job.
Why not?
What's that? What the hell did you just do?
Hey Aaron, did you mean in the very first part, V naught Y1P? Did you mean
So
V1?
the first, no, V naught.
Oh,
sh-
why does that make sense?
No, it's V1.
Never mind. Sorry, guys.
That makes sense.
You could explain this to me?
And all the knots are L or ones, right?
Yeah.
Just seems like trivial, bro.
No, you're getting V1 over L.
It says that the awkward, it says 90% of the
Well,
phenol is
because
extracted.
if 90% is trying to be extracted here, then, I mean, you can either write a material balance between those two, or you can say that the ratio of that to that is going to be not.
Oh, okay. I was looking at the
Can you explain that?
Wait, now you can't.
But
Now you can do a phenol balance because it gave you extra information about phenol.
You say 90%.
Can you find the ratio of V to L?
so
Yeah,
this
you confirm the ratio
90%
of V to L.
is going here.
Yeah, so therefore.
So the amount, so 90% of L naught X naught T
Yeah.
is going to equal that.
Why-
So when you go here, you're going to have this amount is going to be 9 times as much as this amount because 10% has to go here. It's like the same material.
Yeah, so the ratio goes 9.
Wait, Aaron, you can
But-
just say right from there, you can just say.
But you have this, and then it puts it in terms of that. So then you have
So it's over.
equals L1 over V1.
That's how you
Yeah, you rotate it, you multiply V1 up and then L1 down and divide by 3, you get V over L equals
That's the
3.
relativity factor again.
Or, yeah, because 9 divided by
But
3.
we
that
have to
should
use
give it anyway, right?
but they're ones, they're not threes. So I'm not sure yet.
What are you talking about?
The L1, it's L1 and V1.
Yeah, that gives you the ratio that he's
So-
looking for. V over L is equal to 3.
What is pH?
And then I think with the distribution ratio, you can now do a phenol balance by replacing V with L because you know.
We'll take a picture of that. What do you do? Well, it says alpha BH and alpha BP.
What's that?
What was the question?
TJ's laughing.
He says, if I don't get confused and it's screwed once.
Yeah, don't do it totally. You have to do a phenol balance.
So basically, components A, B, and C. Liquid, vapor, liquid.
It'll be on.
Yeah,
On what?
Instead, since you know that the composition y1p over x1p is equal to 3, you can therefore say that y1p is equal to 3 times x1p. And you can replace that out in a phenol balance formula that removes one of your unknowns.
Alpha.
I got a bad memory. Alright, don't worry.
You've already solved that out. You got your ratio of V to L. But now now that we know our ratio of V to L, we can say that L is equal to 3 times V. No, V is equal to 3 times L. It's a lot. I'd have to write it all out.
But you're doing it in terms of L1 and V1. But when
Yeah,
you-
which is, he got that same answer. He got V over L equals 3.
Yeah, but they're ones. You want the initials. You want.
Yeah, you can solve using a phenol balance to solve for one of your flow rates.
I mean, can you say?
Well, I'm just saying, I'm trying to like think this through.
Yeah, me too. But I'm.
Because you know that what? L naught times X naught P is equal to L1 times X1 P plus V1 Y1 P. And we have this ratio, so we know that Y1P is equal to 3 times X1P.
Yeah.
We can plug this into here and get rid of that.
Yeah.
We know these initials, and we know that.
And then we know you can replace V1 in terms of L1.
If you take the derivative.
You should replace V1 in terms of L1 too. So then it's all in terms of L1 and X1 on the right side. Although I don't
Can you
think that-
replace this?
But then you can replace the V1 also.
Yeah, but with what? Your total balance?
With right here, with V1.
Oh yeah.
3 L1.
There you go.
So then L naught X naught equals L1 X1 plus 9 L1 X1.
That's right. X9P.
So 10 L1 X1.
L1 X1P plus 3 L1 times 3 X1P. So now you have these two unknowns. And how do we solve using these two unknowns? How do you get 10 L1? Oh, okay, well, yeah, this isn't it. 9, but you still have two unknowns.
Yeah.
So when do we get?
That was just a.
Yeah.
But then you also have X1 over X naught. Because X1 over X naught, that's going to be 1/10 or whatever it is.
X1 over X9 is 1/10.
Yeah.
Well, look, you got it.
So it basically becomes.
So then you're looking for Z naught.
Yeah, but you can solve for L1, and then once you have L1, you know V over L, so you now know V1,
So then-
you know L1, V1, and L naught, you know V.
So then L1 equals L naught X naught? Yeah. L1 equals L naught X naught. Yeah, it does.
Because this is a ratio of X1 over
Wait, the answer's not 9, the answer's 3.
True, you're right. You're right.
V over L. Yeah, you're not looking for V naught. Dude, he solved that right here. Right here. You move the V over and the L down, and you divide 9 by 3, you get V over L equals 3. That's the answer.
So what were you doing after that?
After that, the question asks for V naught. So what we're doing is we're using a phenol balance and replacing known values so that we can get L1. If you know L1, you know V1 because you have your ratio of V to L. And if you know L1, V1, and L naught, you now know V naught.
So you don't know. Switch the balance around so in terms of the ratio.
Yeah, because the other piece of information we know is the distribution ratio is 3 of phenol. So that means it's 3 times the concentration of the concentration on the other flow, which that's what we did right.
I hate you when you're
Yeah, I think
What's
so.
your
I think it's just supposed to
We used that ratio here, and we replaced it, and we got XP1. And then we also know that from the ratio, we know that L1 is, or V1 is equal to 3 times L1. So we replace that here. We simplified it down to this, and we know also the ratio that X1P over X naught P is equal to 1.
probably
Because
sometime
it's equal to 10% of
I
what
just
went
got
through.
I haven't even looked at them yet. My grader dropped.
So we replace this, and this becomes equal to
1/10
10 L1 times.
X naught, but that then goes in, they just puts you in circles because then you end up with L1 equals L1. Or L naught equals L1.
Okay.
Oh,
No.
that's not useless. L naught equals L1.
How can L naught equal L1? I don't know. I'd have to write it down.
Then V naught, look, if you have L naught equal, okay, so you have L naught equals L1, and you have that L1 over V1 equals 3.
Wait, how do you know L0 equals L1?
Yeah, how do you know that?
V naught has to equal 3 times.
Or you know V naught, you know V1 over L1 equals 3. And L1 equals L naught. So then you, like, it's not going to go anywhere. So then you know that V naught over L naught has to equal 3.
If L naught is
How do you know that L0 equals L1?
Because this.
I'd have to rework it just to make sure.
So, okay, so look. So, you start with this, right, Jake? So,
I don't know.
you understand that part, right? And then you understand this part?
Pass some useful
So
information
then-
our way.
You move these to there.
Yeah.
And then you set it equal to this.
Okay.
Because those are equal. So then you take this. You get L1 over, or you get V1 over L1, which equals 3.
Yeah.
And then
Wouldn't that be 0.9?
And then you have, where'd you get them? Where'd you start the materials?
It's just a balance of L naught times X naught P. Like, go to V1 equals 3 with L1.
Is that a phenol balance?
Yeah, that's a phenol
Yeah.
balance.
So you're doing a, so this is a phenol mass balance right here. Phenol mass balance. And then you replace your,
Yeah.
you want this, and then you put it in terms of L1 X1P. So then you put your V1 Y1 in terms of X1 L1 using this information.
Wait, so what's the initial mass balance? You're trying to do the phenol balance?
This is the,
That's the initial balance, right?
yeah, so you have this piece of information, you have this piece of information.
What's that squiggle?
What?
See the squiggle on the right side of it? V1 squiggle.
Where?
What is that? See what in this box?
This?
Yeah.
This is V1 times 3x1. So
Oh, see.
So
So that's supposed to be Y1.
your Y1, you're replacing, yeah, I don't know where it is.
And then you're replacing the
Your
V1 with
Y1
L1.
equals 3x1.
Yeah.
So then you put that in here.
Okay.
So then you have it in terms of L1 and X1 and L0 and X0. So then that simplifies to 10 L1 X1. And then you replace your X1
What's your proof?
with this information. Or with this information. And so then you use that to eliminate this X naught. So then when you eliminate the X naught,
Information to switch back to.
so then you get, this leads to
That's like.
L naught equals L1.
That's not, it doesn't work.
That doesn't work?
Because what you assumed that x1p over x0p is 1/10, and you can't say that, because it's x1 L1 over x0p L0 equals 1/10.
Okay.
You're right.
I think we're missing a
You
piece of
just
information
derived
on
that.
this.
Oh.
What do you mean?
Like this
The number 4,
balance
yeah.
just derives that
Makes sense up to there.
x1p L1
So you can write
over x0p
It's the
L0
same
equals
kind of balance that we
1/10.
already did.
You
except
can
now it's
derive that,
subscripts.
and that's why it just goes in circles.
So you can just
Because they're the same equation.
this one like we did
Yeah.
before and write a whole bunch of ones like this. And then you can also say.
Use the same alpha as you would normally for that?
Yeah, that's relative volatility.
I'm good at working in terms.
We're gonna just focus on this. Figure that out.
One day.
Then you can write a whole bunch of these relations.
Shouldn't that say alpha AB X A L?
Where is XAL?
I just think